Okay, Advanced Chem students, welcome to Reaction Prediction Lesson 1. We're just going to talk about the basics of reaction prediction and do a little bit of balancing today. Your test grade should be posted online. Let's get started. All right, so these are some of the things that you would see in balanced equations. That's really kind of where we are now. So if you look up here at the top, it has reactants. What we call the things on the right-hand side are products. The things on the left-hand side are the reactants. Reactants will produce products. The arrow in the center can be used as produces or yields, either one. It's not really an equal sign, but in some cases, teachers teach it that way. But you start with reactants, and as a result of the reaction, you produce products. Some of the things you might see in the balanced equation is these labels over here. You may see in parentheses after a compound solid or in a single element, it doesn't matter. You may see gas, you may see liquid. You may see AQ, which is aqueous. That represents or means that the substance is actually dissolved in water. So if you see something like Cl minus with an AQ after it, it means that there are chloride ions dissolved in the water. An arrow going both ways means a reversible reaction. Another way to write a reversible reaction arrow, which I think is cooler, is like this, but it's the same thing. A platinum catalyst would be any catalyst, actually, where the element or compound is written above the arrow. That is considered a catalyst. There is an alternative way to write it we'll discuss later, but this is the best way to do it. If anything is added to the reaction, like a catalyst or heat, it can be, or light even, or electricity, those things are always added over the top of the arrow. So first thing we got to kind of do, now that you guys know how to name things, or most of you anyway know how to name things, is translating a word equation. So I've already kind of translated it here on the bottom, but you would have to go through and balance it. But anyway, when you write it, if it says solid zinc, ooh, my pen is just not showing up. Let's try this instead. Oh, let's try green. So, oh, that's better. Solid zinc metal. So as I've got down here, I would write zinc, and it's a solid, so I would write it like a solid plus. And then I have reacts with aqueous, that's going to be the AQ, copper 2 sulfate, that would be CuSO4, and then I would write my aqueous. And then it says to produce or yields, and I would draw an arrow. And then solid copper metal, I would write the copper, and then afterwards I would write solid plus, and then at the bottom it says aqueous zinc sulfate. Now when I say, zinc sulfate, you guys a lot of times are not going to be able just to write it really quickly. Some of you will, but some of you will still have to write off to the side Zn2 plus and SO4 2 minus and cross them, put them together. That's okay. We kind of expect that. You're not going to have millions of these to do at one time, but if you don't know your ions yet, or you don't know how to name things, it's not late, but it's actually getting quite late. So when we balance it now, once you've got an equation written, you then have to balance it. Balancing is kind of a trial and error process, and the more practice you have with it, the better you're going to be. It is best done, in pencil. We balance equations so that the reactants and products have the same number of atoms on both sides. This will allow it to obey the law of conservation of mass, because they have individual molar masses, and if you have the same number of atoms on both sides, you'll have the same ratio of moles of that mass for either side. You need to correctly write the formulas for all reactants and products definitely before you balance. If you've written them incorrectly or you find that it's not balanced, it may be because you wrote them incorrectly. So we'll do a few of them here, and then we'll kind of close up shop, and hopefully you guys will practice. So coefficients are the numbers that are in front of the individual molecules or compounds or elements, the reactants and products notably. So these here, the coefficients are 2, and if there's not one there, it's understood to be 1. And the coefficient of the water here is 2. So what this means is that 2 moles of hydrogen are reacting with 1 mole of oxygen to produce, 2 moles of water. The coefficients need to be in the lowest ratio, and they need to be whole numbers. It is possible to balance using fractions, and we'll do a little bit of that to show you kind of what to do. They can be used to solve some more difficult problems in the future, but but when a balanced equation is written, it's not written with fractions. So hints for balancing: balance one element at a time. You can balance polyatomic ions if they appear on both sides without being changed. Like if you have sulfate on one side and sulfate on the other side, you can balance whole sulfates together. That's great. Same thing with nitrates or hypochlorites or whatever. You can do those very easily. If you're doing a combustion problem, or if you have something with hydrogens and oxygens, always balance your hydrogen first and then do oxygen dead last. This is important. If you've got, and we'll do this when we do combustion reactions, but you balance hydrogens and then you do everything else and then balance your hydrogens, then balance your oxygens dead last. It will make it much easier to solve those types of problems. So let's do one of these together. So this says zinc and hydrochloric acid are producing zinc chloride and H2, or hydrogen gas. So I'm going to look at this and balance things. So I've got a zinc here and I've got a zinc here. So I don't need to balance my zincs. Let me turn that off real quick. For my chlorines, that I'm not doing hydrogen or oxygen now. I'm doing chlorines. Chlorine, I need 2. You cannot just stick a 2 there. That is totally wrong. When you do it, you must write it as a coefficient. So I would write a 2 here for my hydrogens. Well, that my chlorines. That changed my number of hydrogens. So if I go now and look, I've got 2 hydrogens here, and I've got 2 hydrogens over here. So this is now balanced. I could go back and double check just by seeing which ones I have of everything. I've got 1 zinc, 2, oh, I erased my 2. Look at me and my magic eraser skills. There we go. 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. This is balanced. It's done. Now, some people like to write it underneath, write all the elements that they have, and I'll kind of show you a little bit of that. I don't really do that myself, but there are those that do. Some of the teachers I've taught with in the past do that. They write all their elements down here, like zinc and hydrogen and chlorine, and create charts. I'm more of a trial and error guy myself, but whatever you think is best for you is fine. So on this side, I've got 1 zinc and 1 zinc. Those are balanced. Over here, without this written here, if I were doing it at the beginning, I would have 1 hydrogen and 2 hydrogens and 1 chlorine and 2 chlorines. So if I look at this, I need 2 hydrogens and I need 2 chlorines. If you put this here, you multiply both these by 2, and then it ends up balancing itself. So that is a way to do it. And if you guys go through the PowerPoint that we have in the folder as well, it takes you step by step through that and shows you where they are. But for right now, I'm just kind of doing this as a PDF. Let's do another one. So, and notice you're not always going to see solid, liquid, gases, aqueous on every single problem. A lot of them are omitted, but a little later when we do some reaction prediction, we'll learn where they should be placed if you have them. All right, so aluminum sulfate and calcium hydroxide produce aluminum hydroxide and calcium sulfate. I'll do it with the chart for you, just to do it with the chart with you. I'm going to do aluminum here, and then I'm going to keep, so I've got sulfate on one side, sulfate and hydroxide and hydroxide, so I'm going to keep those together and write SO4 2 minus here. I don't even need to write SO4 2 minus, just write SO4, but anyway, and the calcium, and I've got hydroxide ions over here as well. And then on the other side of the equation, I've got aluminum, and I've got hydroxides, and I've got calcium ions, and I've got sulfate ions. And so if I look at my aluminums, I've got 2, and I've got 1. For my sulfates, I have 3, and over on this side, I have 1. Calciums, I have 1. On the opposite side, I also have 1. And for hydroxides, I have 2. And for hydroxides over here, I have 3. So the aluminums are not balanced. We could do that first. I need to make this a 2. I do that by placing a 2 here. That now messes with my number of hydroxides, but I'll wait and do those at the end. If I look at my calciums, I've got 1 and 1. They're balanced. If I look at my sulfates, I have 3 sulfates on the reactant side, and I have 1 sulfate on the other side. So I'm going to put a 3 on this side and increase my number of sulfates. That does also increase my number of calciums to 3. And to balance those calciums, which I already checked, I'll need to multiply that by 3. And that will end up giving me 6 hydroxides. Over here, I had 2 times 3 is 6 hydroxides. If I look, 2, 3, 3, 6, 2, 3, 3, 6, it's balanced. The chart may help some of you, and that's fine if you would like to use it. I just kind of go through and do them. The more practice you have, I think that is kind of a fact to do it. But again, if you go and look at the PowerPoint, it'll take you through just what I did right there. Pretty straightforward. Now, what I wanted you guys to do is do some of this in class to practice these, and we'll come back and show you some of these. But if you're doing this in class right now, just push pause on the video and wait. Let everybody kind of finish, then get back together, and I'll show you the answers. So go ahead and press pause now, and then come back. So hopefully you press pause and tried this. Rather than flash just all the answers up right away, I'll go through and do a couple of these the way I normally do them. Potassium, let me get my pen going. Potassium, there is one of them. Potassium, there's one of them. That's finished. For my hydrogens, I have 2 and I have 3. So I have 1, 2, 3 hydrogens on the product side. So what I need to do is I need to get to an even number of hydrogens, which is interesting. So I'm going to put a 2 here, which gives me 4 hydrogens on one side, and then I get a 2 here, which would also give me 4 hydrogens. If I go check my oxygens, I've got 2 here, and I've got 2 here. My potassiums are not balanced anymore, so I need a 2 here, and it should now be balanced if I go check. And if I do that, I see that I've got 2 potassiums, 4 hydrogens, 2 oxygens, 2 oxygens, and 4 hydrogens. Yes, this is balanced. Let's do the next one real quickly, and then I'll let you guys just see the answers for the others. So the methane and oxygen, so this is the combustion of methane. I have 1 carbon over here, 1 carbon over here. I have 4 hydrogens over here, and I only have 2, so I'm going to put a 2 here for the number of hydrogens. This gives me a total oxygen number of 4 on this side, so I place a 2 here, and it is now balanced. If I go check, my carbons are 1, carbons are 1. Hydrogens are 4, hydrogens are 4. Oxygens are 4, oxygen is 2 times that, plus the other 2 would also be 4. So that actually worked quite well, and it was super fast. You know I do move fast, guys. But we will do a lot of these. Hopefully you will get to be as quick as I am with it. This pen is just tragic, this eraser. My mistake. All right, so that would be a 2 as well. Just to show you the rest of the, I can do that one real quickly. So on this one, this one here on the bottom, the C6H14 hexane, what I'm going to do first is look at my carbons. Since that's not hydrogen or oxygen carbons, I'll need a 6 here. If I go check my hydrogens, I've got 14 here. Here they are here. And you can go through and check them. That last, this one here, I may go back and do that one with you really quickly. This one right here is a little odd and may have really given you some fits. Let me go back and do that one with you real quickly. Even though we're going to cover this when we do combustion, I'll go back and do it. So